Hello, programmers! You're here again. Today we're going to talk a little bit about dicts or dictionaries or objects, maybe, or hash maps, etc. Many languages call them many names, so I'm going to run this small program that defines a dictionary. So the command for creating a dict is dict. It's the same as in Python, for instance, and you pass some pairs to serve as the key value of a dictionary, and you have this command as. Basically, you could say the same thing like this, like set data and then execute a subcommand. In shell, that will be just like data equals dollar something, like dict, blah blah blah. These are the square braces, and they serve for that, for executing subcommands immediately. But then I have the S, and the good thing about the S, the S is that it works in a pipe, so it's going to receive the value from the pipeline, and it's going to set this name in the current context as a variable, and so you can like print, as I'm doing here. As I said before, remember, now is very much pipeline oriented, so we can just, instead of breaking the pipeline and then calling print, we can simply do this, because the S command was created thinking about this case, where you want to name some data inside the pipeline, but you don't need to break the pipeline. You can proceed, just get this data, give it a name, and process that whatever way you want, So as you see, it's going to execute the same. So one thing about pipes in now is that they are not, they don't do any magic. It's just a little bit of syntax sugar. You can both do this, like print X, for instance, or you can say object X and pipe print. Both are going to print the same thing, So what happens is that the pipe makes the value that's coming from the pipe to be the last argument in a command. And that's it. It's only that, And each command is going to handle these values differently. So inside the command, you can both just consume arguments until the end, or you can differentiate between things that come as inputs and things that are being passed as arguments. But like print does not differentiate anything. So it's going to just consider everything as an argument, whatever it's coming from a pipe or it's being passed as arguments, print is just going to print. Okay. Not all commands are going to continue the data for processing. For instance, print does not do that. So we can use, if you want, a special trick, a special command that makes that for us, but we're not going to talk about that today, because today I want to explore this method from a dictionary that's called run. So what's a run method? What does that do into a dict? Set C3. And then we can print data. Okay, so what's going on here is that we set a value inside the dictionary using regular syntax. We are not using dict specifics. We are just saying set variable in this specific context, in this scope. But since we are inside the run method, the scope is the dictionary, So that's so handy when you have to set a lot of values inside dict and do calculations, etc. So instead of setting the value and going outside, doing the calculations, and then using dict specifics for, setting values there, you can just open a scope, and every variable you're setting inside the scope is going to be a key and a value inside the dictionary, So it's quite handy, quite useful in some cases. Sometimes you want to transform variables inside the dictionary, like, okay, I want to get this promise, like in JavaScript. We are talking about progressive JSON nowadays, so instead of doing that externally, you can do that internally, and that's amazing. Let's go into a brief aside to talk a little bit about this pipeline orientation. So again, we could do this print here. I recommend using the command log, okay? Because things intended for humans should be in the standard error and not the standard output, okay? The standard output is for other programs. The standard error is for humans, for people to read, to explain what's happening on your program, okay? Because in the Unix philosophy, each program should output things for the next program, okay? So the standard error serves for this purpose, to say to the human, to the operator, okay, this is happening. This is happening in plain English, like I am doing this, I am doing that, I, the program, am processing this or that. But the standard output is for the next program in the pipeline, in the shell. But let's say I want to see how's the state of this dict at this point. We're not setting a name for them anymore. So right here at this point, I just created a dictionary with two keys like A and B. And I want to see that, I want to print, I want to log this. So the problem with log is that it's like a terminal command. So can do this, I'm calling it 1 and then calling it 2, or start and finish, or before and later. So that's what happens. The program is going to break because log is not going to take the data, go forward. So it's going to just consume data, and it's not going to pass along in the pipeline. And that's the same case for a lot of commands. And how you do that? Because I want to do that. So in most programming languages, the solution would be something like this: as data, and then log, and then say object data, and call run. So you are breaking the pipeline into pieces. So don't. Now, you're not supposed to keep breaking pipelines for these futile reasons. That's stupid. Don't do that. So the language provides you a way of not having to set a name for data, so you can just process data and without saying, oh, this name is Dick, its name is John or Paul or whatever. You don't need to have that. You're going to use a command that's called arrow, and that's actually run, okay? So the name of the command is run, and you pass to run a subprogram. So everything inside curly braces is called now a subprogram. So you have the main program and you have subprograms, and you can nest them, So in Ruby, that would be a block, or like a block is the name, and some other language called that, I don't remember, but that's like subcode, So the thing with this is that it's parsed, but it's not executed eagerly. It's executed by the command. So you're getting this piece of code as a value, and you're going to pass that to this run command. So what's special about run is that it's going to pass along the inputs, and it's going to pass along the outputs. In this case, this special case of run, whatever comes as the input, it's going to pass along as the output, unless you use a special command called inject. So inject X. So this inject is going to inject this value into the pipeline, okay? And proceed processing this data. But in this case, I don't need it. I just want to log what's going on. So we could use this run command. It's going to work just fine. You can see 1 dict and 2. There's this 3 here, and that's interesting about this kind of thing. But anyways, so instead of writing run, because that's going to be easily confused with the command run, and the commands in line 3 that I'm defining, and then there's the method run for the dict, etc. And also visually, it's kind of difficult to understand that this command is passing along the data, etc. So instead, you can use this alias, that is this double arrow, you know. So visually, you can understand that the data is being passed along to this subprogram, and probably it's going to come out in the end the same, probably. And visually, you can kind of see like a small tree being opened, you know. If you do that in many places, in nesting, etc., you see that actually you're opening a tree of code execution, basically. So every time I log, I do that, just because I don't want the log command to terminate my pipeline. So every time I do that, and in the end, it's going to become a thing for you to do this, to always make this tree, you know, you set a trunk and open branches on your data. Why? Because sometimes you want to do multiple things into the same data, and you don't want to conspurcate your, you know, taint your pipeline with different data. Like the outcomes of each processing branch should not interfere with other branches sometimes, you know. Let's say you're downloading JSON from an HTTP API. So usually you want to handle, like, check if the authorization is correct, or if the content type is correct, etc. So you don't have to break your pipeline in multiple pieces, like object response, get the headers, get this, check this, and break. Object response, get the headers again, do this, do that. You can like open this tree, you know, do something like this. Object response, let's say it's a JSON that was parsed, now it's a dict, so you can do things like this, you know, like verify content type, and if it's not correct, you can return immediately. And then you want to verify data, and then finally you want to process data. You know, you're going to do many things with the same data, and you can do that into a single. Now it's not that much a pipeline as a line, but it's kind of a tree, you know. You open a tree with many execution branches. So you can do this, like get response headers, for instance, and then you're going to, with the headers, do the verify content type, you know. But you can also verify by version, if that's the correct version, for instance. So you open here on the 14 line, you open a new execution branch with the response object as the input, and then you get the headers of this response. And then with the headers, you do two separate things in two separate branches. You're verifying the content type, if that's okay. You verify the API version, and then you can do something like this, like get body, because now we are handling the body, and you're going to both verify and process the data. So now you see that we have actually an execution tree, you know, based on the same data. So if you're processing a big JSON file, processing a response, you're processing a HTTP thing with a lot of headers and body and verifications and validations and etc., you can like open this tree instead of saying get this from the dict, get this from dict, do that, and break your program in a lot of blocks, of different blocks inside the same function, or breaking into many functions, etc. No, you don't need to do that. You can do that in place, basically. And that's it for today. The last thing about scopes is that it's pretty common for your, like in this case, sometimes you have a big function and you don't want to break that in multiple small functions, and you do things like that, like create example dict, you know. I have this thing about doing this column in the end. To me, it reads better in comments. I know many people don't do that. And then we can say exemplify execution trees. You know, so it's pretty common to do that. And now understands that this is common and provides a command to improve the life of the developer, and that's so cool. What we have in now is scope, and a scope has a name, you know, and then you can do this. You can create a scope, and what the scope is just a name. You're going to give a proper name, a descriptor for this piece of code, and that's it. You know, why? One, visually it makes sense. You can like understand, oh, okay, this is a scope that creates an example dict. You know, like the variables set here are going to be available outside of this scope. You know, it's just a name. So visually it's cool, like, okay, understand. Maybe I could use the syntax highlighter to give scope like a different background and make that visually more appealing. But it works nice in the visual side, and also, let me turn that into a scope too. Here. But also because you can say this expected error, and you can say error, this is expected. And then what happens is that, oops, okay, response does not exist. Let's get rid of this one. You see, like I printed a dict, etc., and then we have this error or exception. It's a user exception because I call it with the command error, and it's going to print this expected exception, expectation. It's different. And you can see that the scope, you see this S here, is for scope. So what's the scope? Is run, that's the name of the command, run, / expected error, that's the name of the scope. So if you have this big big command with multiple things going on there, you can separate into scopes, and when an error occurs, you can take a look into the scope and say, oh, I know where it is. You know, I don't need to investigate too much because the name is here. It's on the command run, and in the scope, let's say it's do something very important, you know. So the scope is run / do something very important. I understand, like, oh, okay, like the name of my command or procedure or whatever should be clear enough, but inside this procedure I might have many things going on, so I can, you know, easily name them, and that's very cool. Okay, so yeah, that's it for today. Thank you guys, see you in the next one. Bye.